Hi everyone. Today we are going to discuss our second lecture series in structural analysis and design. So these are the topic I'm going to cover in next lecture sessions. So first I'll talk about types of supports. Then we'll move on the types of loads. Then we'll study what are the types of dead loads, permanent actions, what are the types of variable action in structure. Then we'll study how to calculate the total load. Then also we'll talk about a little bit regarding the load combination for limit state design. Okay, so let me start with the supports. The definition of supports, so we can say the supports are the connections or restrictions for the member from movement or rotations. You know, there are two type of phenomena we can talk about when you comes to the material movement, that means object movements, dynamics and statics of the objects. So first one is the movement. So that means, let's say you have an object. The object, without changing its orientations, it change its locations. Then location can be any directions, maybe horizontal, vertical or inclined directions. Whatever the directions, the location of the object is changed. So this is we are calling as movement. Similar to the movement, there's another kind of phenomena is there, that is called rotations. So that means you have an object here. This object is change its orientations rather than its moving. For example, if you try to rotate this object in this directions, just it will change its rotations. Here, the earlier the orientation was horizontal, now the orientation is some other plane, some other inclined plane. So this is we are calling as rotations. You know what we define as a structure, that means supports. Now your supports, it helps you to prevent from these two type of action in your member, right? So that means your supports prevent the movement of the part, also it will prevent rotations, right? Okay, so let me talk about the types of structures. There are many types. So here we are going to discuss only the certain type of structures, sorry, supports. So you know here, so these are the types of support we are going to discuss in this section. First one is the roller support, pin support and fixed support. So these three are most common in a structural engineering structures. So in addition to these three, there are other type of structures, that mean guided supports, pin connected joints, fixed connected joint, spring support, spring joints. You know, so these supports, so nowadays is also common in a structure. So particularly the spring supports and spring joints you can see in the damping structure. So these are from what is that, your frame structures, you can see this kind of supports. So we'll discuss each type of support separately, so you will get some idea what is actually these support. First we will move on with the roller support. So before going to the definitions, so let me talk about these two pictures. You can see here in these arrangements, this support is an intermediate support. That means it is in the middle part of the beam. So here you can see this is one of the end of the beam. if you take these two supports, when it comes to roller supports, so this will be the typical arrangement when if the support is at the end, so this is the arrangement. If the support is the intermediate of the beam, this is the arrangement you will get. So these two I have got from the bridges. So similarly, the similar supports, it's very rare getting in buildings unless if you are using free cast members, right? Okay. So let me talk about the functional objective of these two supports. So what we define as a roller support: provide restrictions in vertical, that means one direction, to the connected part of the members. If you look at this structure, this supports, so whatever the load you are applying here, so the support is never allowed to move vertically downwards the members. That means when you are giving any vertical load, support give the resistance in vertical direction. In roller supports, we can't say always vertical. Sometimes what is that? You can protect the horizontal movement of the structures. That's also possible. In that case, vertically you are allowing the members. But it's very, very rare in structural engineering. But there are some cases. Similarly here, in the end connections, so when you are giving any vertical movements, your support will provide the vertical restrictions against the vertical movement of the structure. But it will allow your structures to move horizontal. Always it will allow your structures to rotate. Clear? For the rotations, it won't provide any what you call restrictions. Here also, this part can be rotated, this also can rotate, right? So that means roller supports, it will provide restrictions only in one direction. This is very important. This is the real arrangements of the roller supports. But when it's come to our notations, this is the notation we are using in structural engineering. So this is these three, we can say the rotations. So different books, they use different notations, but these three are the commons. So some books they use this one. Some books, most of the books, they use this part. But this is also very, very uncommon, but this is also represent the roller supports, right? So let me move on the next one, pin support. Pin support, so let me read first the definition. Provides restrictions in both vertical and horizontal to the connected part of the member. You can see here, so I hope this picture is clear to you. So here you can see, so if you want to look at these arrangements, so if it is not clear, you can look at here. There's a special connections provided the member and the support. So what you can look at here, this member here, it will protect from horizontal as well as vertical. If you give any vertical load, the support will provide the vertical restriction. Also, it's never allowed to move your member horizontal as well. Horizontally, if you provide any load, the support also give horizontal restriction. So, but in your roller case, it will that will protect only the vertical movement, not horizontal. Right? It's very important. So another one is these structures, it never provide any restriction for rotations. Your structure, your member can rotate. Okay. So similarly here, so this is the inclined pin support. So if you give any forces this way through your member, your support will give the restrictions opposite of that. Also, if you try to move your member horizontal, the support will give horizontally. If you try to give any load in the vertical reaction, support will give vertical, right? So that means this is, we can say, the resultant reaction of the support. Here you can see as I mentioned earlier. So when you are try to rotate this structure, this part, it will free to rotate, right? So that means your pin support will not provide any restriction for the rotations. It is very important. Okay. So let me come to this picture. So this picture, it is not like behave your typical pin supports like these two. So this is we are calling as the connection for internal hinges. Internal hinges means when you are connecting, when you are constructing very long span members, it's very difficult to construct as a one members because of the material availability, restriction of construction. There are many reasons. So in that case, what we are doing, we are connecting two members using this kind of arrangement. This is we are calling as internal hinge. That means connecting two member in the middle of the structure. So this is also kind we are calling as internal hinges. This is also kind of a pin support. That means it will provide horizontal as well as vertical restriction. That means it will never allow to both part of the member moving horizontally as well as vertically. That means when it is when you are trying to move the vertical direction, both the members it will go down or up at the same times. You won't get any relative movement. So that is very important here. It will protect from the relative movement. So when you talk about the notation here, so this is, you can see, if it is the end of the members, this is the arrangement, this is the notation we are using. When it is the middle of the member, this is the notation. Try to identify the difference between the notation of roller support and pin support. Roller supports, there are some roller arrangement, right? Here, this is the notation. When you talk about these internal hinges, this is the notations we are using it. You can see the internal hinges also here. When you try to rotate the members, it will allow your member to rotate in both axes, right? So that is you can observe here in these notations. It will allow your rotation about these 2 points. It will not provide any restriction against the rotation. So let me come to the next one, the fixed support. Fixed support, before going to the picture, let me read the definitions. Provide restriction in both direction, that means rotation, and position, vertical and horizontal, to the connected part of the member. So that means if you take this member, this feature, so if you take one part of the member separately, it will look like this. So what you can observe here, if you provide any what you call the horizontal forces in your member, the support will give the horizontal restrictions. Similarly, if you give any vertical force on the member, your support will give the vertical restriction. Not only this, so that means it will keep the position of the structures. This point, it never change, always will be in the positions. For example, if you measure these positions from the ground, let's say from the ground this is 3 meter, that means always these positions when you are giving these forces will be 3 meter. The position won't change. That is the meaning of the position. So let me take another one. In addition to these two, until now this is similar to the pin support, but in addition to these two, there's another restriction it will provide when you are trying to rotate the member in this direction. Okay, when you are trying to provide the member in this direction, this vertical part of the member, it will never allow to rotate. You can imagine that, right? So these two parts, when you are trying to rotate the member in this direction, this part is never allowed to rotate. It will provide some kind of what is that, counteracting actions regarding your movement. So therefore it will provide some restrictions in the rotation as well, right? So this kind of supports we define as fixed support. So this is the notation we are using for fixed support. Some books they follow this one, but some books they use like this. For these kind of moments, that means supports we are calling as fixed support, right? Okay, so let me move on to the next one, the guided support. So what we define as a guided supports, we can take the exact definition like fixed pin roller. It will provide the restriction based on its nature of the connection. So you have to understand, based on its nature of the arrangements, you have to understand the restriction in which basis. So for example, so let me come to this one. You can see if you give any horizontal uh, force, your support will give the horizontal restriction. It will never allow to move horizontally. But if you give any vertical one, your support can slide here. You can see in these arrangements, your support can slide in vertical direction. That means in vertical direction, your support will not give any restrictions, right? But when you try to rotate this member, you know, this when you try to rotate this member, these vertical portions, it never allow to rotate this part. It will give the restriction in rotation. So that means it is not a complete fix, it's like a partial fixed. So this kind of support we are calling as guided support. So okay, so this is different from the fixed support. You have to understand that one, right? The fixed support in all vertical horizontal restrictions, also rotation. Here vertically it's allowed, then vertically you won't get any restriction from the support. So this is the notations we are calling. You can see in these rotations, it's combination of everything. Horizontally, if you give horizontal, support will go on horizontal. If you give rotations, so this part, the whatever the part here, it will give the restriction regarding rotation. But this roller it shows, it can vertically move, right? Okay. Let me go to the next one, the spring support. The spring supports, there are many kind of spring support. So spring support means, so we can define spring support partially provide a restriction based on its nature of connection. That means it will provide a restriction, but certain kind of what is that, settlement. For example, here, if you give the vertical force here, it will give the restriction, but not completely. There should be some settlement here, right? Because of spring, there will be some settlement, but with that settlement, it will provide the restriction. But in all your previous supports, the settlement is not there. Okay, you have to understand that one, right? Similarly, when you are giving rotation in some springs, when you are giving rotations, it will give, what is that, the restriction against rotations by allowing the certain kind of rotation, right? So these are the notation we are using for that. So this is vertical springs. So this part, it will give the support, that means restrictions with a certain settlement. How to calculate these restrictions we will discuss later. For the moment, you understand the types of support behavior, right? So here you can see, this is like I said earlier, when you are giving rotations, it will give the restriction with rotation, but certain restriction, it will allow the certain kind of rotation. That means certain kind of rotation means there's a small angles here. Similarly, this one. So this is for the beam, this is for the frame. Frame is, we discussed the Fortel frame in previous structures, basic Fortel frame, right? So this is basic kind of Fortel frame. In this case, for example, in this joint, so you will get this kind of moments, right? Sometimes you can use the spring here in some structures, particularly in the damping structure, right? So this is the spring support. So next one, the pin connected joint. What we define as a pin connected joint, this is shows the analogous behavior, the same similar behavior like pin support, but the difference is this is in the frame structure. Right? You know what is frame? We discussed in our last lecture. So this is the notation. You can see here these two A and D. A and D, it's our typical pin support. So this is not a pin connected joint. So what we define as a pin connected joint, our B. This is intermediate, that means in the middle, that is connecting two members of the structure of the frame. So this is like an internal hinge. You remember what we discussed under the pin support? The internal, it is kind of an internal hinge we are using in the frame. So that's what this is, pin connected joints. So this is also pin connected joint. But this is hinge. Hinge means it pin. That means what is the meaning of pin? It will restrict vertical and horizontal, but it will allow the certain that means rotations, right? So it will allow the rotation. For if you are, when you are giving the rotation and this part, your entire part is, it will rotate, but there is no any restriction regarding rotation. So that is the meaning of pin. You have to be very clear in that, right? Okay, so let me come to the fixed connected joint. The similar to the pin connected joints. So here what is that? You will get the rotate, that means restriction for rotation as well. So this is the notation we are using. You can see. So this is pin support. Okay, pin ended columns, you will get fixed connected joints. It's possible, right? But here you can see this is your typical fixed support. With this typical support, this is typical fixed support. But this part, so what you, this is here, this is your, what is that? Fixed connected joint. So what is fixed connected joint here? It will provide the restriction vertical and horizontal movement as well as the rotation, right? Okay. Right. So why I'm explaining these things by giving some effort. So you know, in real structures, when you are doing the design of the structures, so based on the what is that, the connection you provide, that means you have to understand based on your functional requirement of the buildings, you have to restrict the movement of the directions and rotation as well, right? So based on the support behavior, you should be able to judge what kind of supports you are providing there. It's very important. But in your books, all the books, it will provide what is that, pin support, fixed support, what is that? But as an engineer, you should know what is the physical meaning of fixed support and roll support, right? So let me give some other hints. In concrete structure, how can you make sure which kind of supports you are going to provide, right? So for example, concrete structures, you won't get that kind of arrangements like I saw in the previous photos, rollers, intermediate hinge. So what you are doing here, this is very important, right? Because we analyze the concrete structures. Concrete structure, there are two kind of arrangement you will get. One is the, what is that? The connection like this. So in this case, you have to think about this way, right? So even column is coming, we are considering the beam is continuous, right? Then there are two columns and top and bottom, two people, they are pushing these members upward and downward. So what is this arrangement? You have to think about this one. So because of these two peoples, the position of this beam, it never change. That means if it is 3 meter high from the ground, it will be 3 meter high always. But So this part, if you try to apply any rotation here, so this part can be rotated. Small notation, I am not talking about the big one. So whatever the settlement and rotation we are talking about here, it's a very small amount. It's a millimeter or very decimal point rotations. So that means here this case you can consider this kind of support as, what is that, your internal roller, also internal pin, no problem, right? Because beam you won't get any horizontal force, we'll discuss later. Under the beam you can assume both roller or internal pin, right? So this member is continuing, right? Here also member is continuing. So again I am repeating, when you are getting this kind of arrangements, for example in this picture, if you take this large beam, these supports, whatever I am marking here, these supports you can assume as internal roller. Then this is these supports, this one. Okay, so what is another kind of arrangement? You will get another arrangement at the end. At the end, okay, here also you have to think about, if the beam is end here, you have to think about your beam is continuing until the end. Here two people are pushing top and bottom. Okay, here what kind of the support you can consider here? So there are many arguments is going on. So whether can you take as a simple support? I mean, simple support means, you know, we discuss in the simply supported beam, pin and roll. These two supports we are calling as simple support. So that's what many argument is going on, whether can we consider as a simple support or fixed support. My idea is, if you want to get very precise results, so this is my idea. For example, let's say this width of the column, I'm marking as B, right? Right? So this is, in this case I am considering shape. If it is a different, for example B1, B2, so what you have to select as a B, you have to select the minimum, right? You have to select minimum B1, B2, right? Then you will get depth of the beam here. So let me take that is H. So what is my idea is, if you get your B is greater than your H, that means B is greater than, you think about this way, your these two, the holding force, maybe we can say the two people are pushing, the pushing forces, it's higher, you will get high force, high pressure. So therefore in this case you can consider this support as fixed support. That means it never allow, you know, it's clear horizontal vertical movement is restricted. When you are giving the rotations based on these two forces, these two people strength, it will determine your rotation of the structures. So in this case you can consider as a fixed. When it is other way, what is that? So in this case you can consider, what is that? Pin support. In most of the cases in concrete you will get this one. So this case you will get particularly in the precast concrete member, because in most of the cases you will get the slab here, because you know slab and beam we are constructing at the same time. So what we consider is the depth of the beam here, including the slab. Here in this case, this is the depth of the slab, depth of the beam. So therefore most of the cases you will get this one, second one, right? Okay, so I hope that means everyone can able to understand what is the physical meaning of supports, how can you provide a judge most accurate supports in the given structures. I hope you have enjoyed this video. We'll meet in next lecture sessions. Thanks a lot for your watching. Subscribe for future updates. Thanks guys.